Good morning. William Vambenepe. My Twitter handle is my last name if you can spell it and if you like bad puns and tweets about data processing. I work for Google Cloud. I lead the PM team for data processing services on Google Cloud. But even though I work for Google Cloud, even though I really like competitive situations, when I talk about separating the clouds, these are not the clouds I'm talking about. And so as soon as I step off the stage, I'm more than happy to have those discussions. I really enjoy them. But here today, I'm going to be talking about, OK, I'm one slide behind in my deck. That's why that didn't make sense initially. So these are not the cloud I want to talk about. The clouds I do want to talk about are these clouds, and specifically the way they show up in satellite imagery, such as this, where they have the really annoying habit of obscuring what's behind them. Sometimes you take satellite images to see the clouds for meteorology, and then you love seeing them. Other cases, you want to see what's under them, and they become a nuisance. And so in cases like this one, it's actually quite easy to find them and detect that they are obstructing the view. In other cases, it can be quite a bit harder, especially when there are mountains, especially when there is snow. And clouds and snow have a tendency to look alike. And so that's a real example coming from Airbus, which, in addition to building airplanes, also has a business selling satellite pictures from their fleet of satellites. And they want to sell quality pictures to their customers, which means detecting when clouds are obscuring the view so that you can retake a picture when the clouds are not there. And so these are the kinds of images. And on that one single image, a trained operator can pick out what's a cloud and what's snow. But a trained operator cannot do that on 1,000 images per second. And satellites produce a lot of images very quickly, and people want to consume the data quickly. And so in this case, Airbus, using TensorFlow on Google Cloud Machine Learning Engine, was able to create a model that makes this determination quickly and effectively. And so hopefully you were doing your homework as I was talking, kind of deciding if it's snow or cloud. Of the 4 white patches here, now time's up, the answer is it's mostly snow, but the upper right is clouds. And so when the clouds are trapped in the valley, they actually adopt the shape of the valley. And so they don't look like clouds. They look more like snow deposits. And so that's the kind of thing the model has to do reliably, quickly, across large amounts of data. Now, why does it matter? It's not just about satellite imagery. I think there's a fundamental point under here around the value of the data and how processing systems like machine learning allow that value to come out. And here's a second example. This one, a Google product, Street View, which I assume many of you are familiar with as a feature of Maps. And that's really how it started. 12 years ago, it was a nice feature of Maps. It still is. I love the feature. What has changed since then is that this corpus of images captured over the last 12 years actually has a lot more value than initially intended. Why? Because we can now easily, efficiently extract additional information. What store, what's being advertised, what's in the window, and 2 years ago, was this the same store or some other store? This is really useful, and that's something that was not intended. What has changed is not the pictures. It's the same pictures. I assume slightly higher resolution now than 10 years ago, but that's not the important part. What really has changed is the power of the processing tools available. And that's really the core of it. Beyond machine learning, beyond specific tools, is the fact that the value of the data is not an intrinsic property of the data itself. The value of the data is really a function. It's a function of the data as well as the power and ease of use and cost and speed of the processing system. And that second part of the equation, that's really what has been changing drastically over the last, 20 years, in the case of Google, going back to how we built it for ourselves, last 10 years in the cloud context of building and offering system that not just offer new and powerful capabilities like TensorFlow, which we talked about, like Apache Beam to unify batch and stream and make stream very easy, but also make them much easier and much more effective by building serverless systems from the point of ingestion, stream processing, data warehousing, machine learning, and really expanding the range of possibilities, which is why now is the time to not just get familiar with it, and please come to the booth, we'll be happy to talk about it, but then based on that, reconsider the value of the data that you have or that you could have and haven't been collected so far, and see in the context of this available technology how much more you can do with it. Thank you very much.